Okay, so 9-3, day 2, we're just going to do a lot of examples. In fact, you're going to do the examples, and I'll just keep checking in on you, see if you're doing it right. But this is the one I gave you for homework. I really gave you the center and the vertex, yes, so you can find the other vertex. And there's something else you can figure out from knowing a center and vertex. A, that's right, little a. Okay, so I would suggest that you draw whenever you can. I can't force you to, unless I write graph. Okay, so these are your three givens. This is the center, and this is the vertex. So just the fact that this is 5 spaces is important, because that is A, you see? A. A is the distance from the center to a vertex. So I was basically giving you A almost for free. Why would I give you a focus point? What would be my reasoning for giving you the focus? Help you find what? Little c, correct. So this is 3 spaces, obviously, and that's little c, the distance from the center to a focus. So if you're not sure why is the 5 the A, why is the 3 the C, it's because maybe you missed yesterday's lesson. We said yesterday that the distance from the center to the vertex is 5, distance from the center to the focus is 3, or is C. A and C I meant. So anyway, you're being given both of these on a silver platter. Okay, and there's a relationship, a geometric relationship between A, B, and C, and it looks like this. So you can use this to find what? B. So let's go ahead and plug in our numbers. I'll pause for a second for those who didn't get this done properly. But you know A and C, why not find B? So go for it. By the way, you use this formula on practically every single problem. So if you haven't used this formula yet, you probably never finished the problem. Okay? Okay, so hopefully you plugged in the numbers, right? You should have a 25, and then it's minus b squared equals 9. Just plug in the a squared and the b squared. Okay, and then you should be able to get b. So actually what's probably more important here is b squared, not b. Why am I writing 14? I meant to write 16. Why is it more important to have b squared for this question? If the formula requires us to have b squared, right? Okay, so here's the question. Do I write my answer as x minus 5 squared and y minus 2 squared and put the 25 here and the 16 here? Or do I put the 16 here and the 25 here? That's the only question I have left to answer. Which of these is the correct one? Where do I put the 25? Where do I put the 16? That's the only thing I have left to figure out. So, who gets the 25? The x's or the y's? That's the last question for this problem. Okay, so the easiest way to tell is to look back in your notes, right? Or if you've already started to make your flashcards, look on there. But basically, whenever the points are stacked like this, you're dealing with a tall ellipse, and tall ellipses have the bigger y denominator. So that's easy to understand. When y has the bigger denominator, it's tall. Big y. All right? So let's put the 25 under the y's. What's that?
So if they all have the same x point, then put the larger one under the y.
If they all have the same x, then they'll be stacked vertically like this. And if those points are stacked vertically, you're right. We would put the larger number under the y.
And it's like inverse, if they all have the same y point, you put the larger one under the x.
That's correct. So it turns out we're going to actually put the 25 here to make sure that this is a tall and skinny ellipse. Because if you put the 25 under the x's, it's going to be wide and not so tall. Okay? How many of you got this problem right? Okay, the numbers are pretty friendly. The 16, the 25, the 9, it's all very friendly. Do you suppose that on most of my examples I would be able to keep nice Pythagorean triples going for very long? I can't do it. As soon as I change, you know, A to 4 and C to 3, we unfortunately lose this nice Pythagorean relationship. So don't be surprised to find rad 3s and rad 5s and rad 2s in your answer all the time. Okay? Happens a lot. In fact, what I think we should do right now is everybody write this down. Root 2 is about 1.4. Root 3 is about 1.7. I had you memorize these when you did your unit circle. Remember that? So make sure you memorize those 2 decimals, okay? They're on the board there. How about root 4? That's just a dumb question. Root 5. Do you even know what root 5 is approximately? It's 2.24, and it's an important one to know. You can round it to 2.25 if you want, but it's around 2.24. It's closer to 2.24. Who cares about root 6? I hardly ever see it happen. But it seems like we run into these 3 quite often, okay? For example, you might be working on a problem and you have like root 20. Well, root 20 is basically 2 rad 5. So it'd be 2 times 2.24. It's about 4.5. Okay? So please try to memorize these so you're not pulling a calculator out every 14 seconds. Okay, you guys are really supposed to be beyond that. And a lot of our graphs are estimated sketches anyway. So just leave the rad 5 in the answers. But when you sketch, just get it somewhere between 2 and 3, right? You know I'm very picky with decimals, but only when the answer is supposed to be given as a decimal. I don't even want decimals in your answers. The only reason you would use decimals at all is for plotting purposes, and your graph paper is not that accurate anyway. So please write these 3 down. Oops, I just erased. Please write these 3 down, everybody. I need you to know those, okay? Otherwise you're going to have trouble with my test. Okay, so let's go on and look at another example. So I'm going to actually have you just work on a problem. I'm going to give you 3 different things this time. This time I'm going to give you the 2 foci. Of 5 root 2 comma 4, negative 5 root 2 comma 4, and also the length of the major axis is 16. Okay, so I'm going to call these clue 1 and clue 2. What I've actually given you here is at least 3 important facts. Okay? But the goal is to write the standard form. So write the equation of the ellipse in standard form. I'm going to pause the recording and let you work on this for several minutes. Just see what you can do with this problem. You might want to sketch it. You might want to realize that root 2 is about 1.4. Don't use your calculator. See what you can do. At this point in time, clue 1 is really giving us a lot of sub-clues, right? First of all, you have 2 points that have the same y-coordinate. That's a huge clue right there. So the fact that you have 2 points, one on the right side at approximately 7, 4, and one on the left side at approximately negative 7, 4, just the fact that the foci are side to side like this tells us something. Can you show me with your hands what the ellipse is going to look like? Yeah, long and short, right? So wide, really wide. Exactly. Okay, so are these the sort of endpoints of the ellipse? No, the ellipse is probably something like that, actually, right? The foci are inside the ellipse. So that's annoying, but start. Why else would I give you the 2 foci? What else can you just pull out of that, Carly? What else do you notice here? What came to your mind when you saw the 2 foci drawn there? You can get the center. That's right. The center is located where on an ellipse? At the center. Correct. So it has to be halfway between. So where is the center? You can give me the coordinates right now. 0, 4. So that's a huge clue. So we already know which type of standard form we're going to be dealing with. We already know where the center is. All this just comes from the first clue. There's more. The first clue also gives us one of these three things. You tell me. I gave you the focus, and the center is implied. So which of these three is basically handed to you on a silver platter? A, B, or C? Not A. Not from clue 1, anyway. From the first clue, C is implied. Yes. So C is this distance here. I always like to draw this segment green. C is this distance. And if it goes from 0 out here to 5 root 2, how long is it? 5 root 2. Okay, so that segment is known. All of that came from clue 1. We haven't even looked at clue 2 yet. Right? Okay, so take a minute now and look at clue 2. It's supposed to be 16 all the way across from purple to purple. Okay, if I had to give you another hint, it would be that whenever the major axis is 16 units long, they're telling you the entire length here is 16 all the way across. So the implication is that halfway would be 8, right? So they're actually giving you A. A is 8. You see? So armed with the fact that A is 8 and that C is 5 root 2, maybe you didn't think to use this equation, A squared minus B squared equals C squared, but we use it on every problem. So you've got to use that thing, okay? Please do that formula now to get B. And do not use any decimals. Use C equals 5 root 2.
5 root 2 squared, if you do order of operations, it's root 2 squared and 5 squared, and then the multiply together.
That's correct. Yeah. Okay, so plugging in the numbers, this is just basically 64. And then we have minus b squared is equal to, and then just be careful with this, you're squaring 5 root 2. That's exactly 50. Now if you squared 7, 7 is the decimal that's close to 5 root 2. You're going to get 49 here if you use the decimal, so don't do that. Just go with 5 root 2 squared. That's 25 times 2. All right, so you should have this equation. 64 minus b squared is 50. Add the b squared over. Subtract the 50 over. B squared is 14. This was the last thing you needed. Now you're ready to write the equation. So it is a horizontally long style with a center at 0, 4. The larger number would then go under the x's, the smaller under the y's to keep it long in the horizontal realm. Okay, so this would be the equation, and 14 is the correct denominator, not 15, 14.
Keep the minus 0 there.
No, you can erase the minus 0. I'm just showing it for effect. But yeah, you can certainly erase the minus 0. Okay, any questions on that one? So you mostly solve it yourself that way. Let's look at another one. Let me find my next example here. Okay, so for our next example, I guess this is example 2. You're going to be given x minus 2 squared over 25 plus y plus 6 squared over 20 equals 1. And this time you're going to find, okay, so what are you going to find? You're going to find the center. That shouldn't be very hard. You're going to find the vertex points. There's 2 of them, vertices. By the way, the vertices are the 2 endpoints way out on the sides, the furthest 2 apart, right? You're going to find the foci. You're going to find the co vertices. That's a new word for this problem. You could probably guess where those are. Where do you think the co vertices are? It'd be these 2 points. These are the co vertices, okay?
Yeah.
What else can I have you find? Let's have you find, let's definitely have you sketch it, right? And let's have you find the intercepts. The intercepts. Obviously that means X intercepts and Y intercepts. And let's have you find domain and range. Domain and range. These ellipses have very tight domains and very tight ranges. They're really not very big. They don't span the whole x-axis or y-axis. They're all kind of contained between 2 certain x's and 2 certain y's, you see. Yeah, so this is an interesting question. Yeah.
You put graph, we need to graph it.
You do need to graph it. it can be kind of a rougher sketch, but by the way, if you ever have to do all of these things, the verb here is discuss. So if you're asked to discuss, it basically means do all of this stuff.
Does that mean intercepts and domain range do all the time?
Yeah, for my class, if you see the word discuss, it means find everything. The only thing we're not finding is some of the features we haven't studied yet. Like, there are actually a lot of other features. Like, there are 2 directrix lines, and there's what's called eccentricity. You can put it in polar form. There's all sorts of fun things to do with it. But let's just stick to these here, the ones I just wrote on the board. Discuss. Okay, let's go over this problem together, okay? So, with all these things to do, there's not really any particular order to it, right? So do things whenever you're comfortable with them, right? So, I don't know, you might want to sketch it as you go, or draw one big graph at the end, or whatever. But for sure, the center is 2, -6. That's not a mystery, right? So that we can write that down. That's pretty straightforward. 2, -6. A is clearly 5. And B is root 20, also known as 2 rad 5. And just for plotting purposes, we should know that that's about 4.5. Why? Because, well, rad 5 is 2.24. So you double it, you get 4.5, almost exactly. Okay, so that's good to know. And then you can also find little c, if you wish, at this time. So you can use this cool little formula. By the way, why is that thing even true? That's a great question. Glad you asked. You should look and see why that's true online, okay? But for now, we'll just use it. 25 minus 20 is c squared. C is clearly root 5, which is approximately 2.24 if we should need to plot, right? Okay, so we kind of have A, we've got B, we've got C. I'll highlight them. So we have A, B, and C. All right, let's go now to the question of plotting and stuff. So I think we should start sketching. That's what I would do. So let's get this thing going here. We know there's a center at 2, -6. We also know that since the denominator, right, is larger on the x's, it's going to be which way, like in terms of orientation? Should be horizontal, right? Okay, so we know that it's going to be horizontal. That's a big clue. So we're going to be counting to the sides, right? So starting at 2, -6, we'll count to the right 5 and to the left 5. Okay, so let's go 5 spaces to the right and 5 spaces to the left. So here's how I do this. I usually write down my center over on the side of my paper like this. And then if I want to go right 5 and left 5, I just put a little plus or minus 5 under the x. So this tells me exactly where my vertices are. 7, -6, -3, -6. Okay, so 7, -6, -3, -6, and I can plot those. All right, so let me clean this up a little. So you can kind of visualize the ellipse. It's like this. Is this too small? Can you guys see that? Okay. Foci, you don't have to do that next, but we might as well. We're going from the center, right and left, just rad 5. So 2.24 spaces to the right, 2.24 spaces to the left. That puts us in those spots right there in green. If you want to find the exact location of those points, just come over here where my center is on the left side of the whiteboard and just do a little plus or minus root 5 right there. So I would actually expect you to write your foci like this. 2 plus rad 5 comma -6, 2 minus rad 5 comma -6. I don't want any decimals for my answers. Okay? All right. Co vertices. Now, co-vertices are the 2 points on the top and bottom of this ellipse, right? So the co-vertices are going to show up right about there, right about there. And I don't know if you noticed this or not, but since B is 4.5 and A is 5, notice that 4.5 and 5 aren't all that different. This thing is pretty round. Like, it's not really that stretched looking. It's fairly circular looking. We call it a low eccentricity, which just means it's not real oddball looking. Looks almost circular. So the 4.5 and the 5 are not too different, you see. So it looks fairly round when you sketch it. I need to tidy up those 2 points, those purple points. So where are they going to go? I'm going to be going from the center up 2 root 5 and down 2 root 5. So you can just write that over here on the left. Just take your center and add 2 rad 5 to the y. Subtract 2 rad 5 from the y. Those are your exact answers for co-vertices. Or just think of it as -6 and you're adding 4.5, -6 and you're taking away 4.5. So it just basically ends up right in here somewhere. Okay, so the ellipse is close enough for sketching purposes. We're not using graph paper. That's good enough. And for co-vertices, we're going to go with final answers 2, -6 plus 2 root 5, and 2, -6 minus 2 root 5. Now, some teachers give their students formulas. So they'll say, so your co-vertices are going to be at 2, or at h, comma, k plus or minus b. That's ridiculous. Okay? Look, draw the picture, go up and down. Okay? You don't need formulas. You need to count your spaces, add your numbers, etc. We've already got a decent graph. Intercepts. You'll notice right now that there are no X intercepts. Okay? But let's show that there's no X intercepts. How do you find X intercepts? How do you do that? Set your what? Set your y equals 0. So let's do that. Let's set y equals 0 to get the X intercepts. I'm expecting garbage to come from this. Let's see. So we have x minus 2 squared over 25 plus y minus 6 squared over 20 equals 1. But we're planning on putting in a 0 here. Show me that this produces garbage. Go ahead. Not on the calculator, but show me why this produces nonsense. Go ahead and do it. Do it on your paper. Show me why, mathematically, this is going to produce nothing. Okay, go ahead and work it out. It's important you understand that when we get a no solution, it's because the equation won't give us anything. Not just because the graph isn't crossing the x-axis. Okay, so hopefully you're getting nonsense because you have x minus 2 squared over 25, and then this is 36 over 20. You might as well write this side as 20 over 20, same thing as 1. But when you subtract over, what happens? The right side is negative 16/20. And at this point you should feel awkward right now. Like something's not right here. Yeah, why are you saying it, that imaginary?
X squared is never going to come out as, negative.
Yeah, how are you planning on making a negative by squaring x minus 2 and dividing by 25? That's impossible. Or if you pursue this any further, just multiply by 25 and you'll be forced to do what? Square root, and you're not going to be able to. Right? So we end up square rooting a negative at some point, and I pops up, and I doesn't mean anything. X-intercept is I. What does that mean? Okay, so what I'm saying is this is going to yield, this is 4/5. When you multiply this over, you're going to have basically a negative, that's 4/5 of 25. I think this ends up being just 20. And there's no way you can solve that.
Can you add an ellipse on an imaginary plane?
Yeah, you can do that sort of thing. But your equations are different, right? It's not that we can't draw such things. It's just that that's not the topic of our lesson, right, at all. And it's way out of the boundaries of what we're trying to discuss. So these are real curves on a real plane. So we should not be dealing with I at all. Okay, so much for y-intercepts. X intercepts. Let's find the y-intercept. Now graphically, do you expect to find any? Two of them, right. You can see them on here. There they are. I just put stars on them. So we would expect those to exist. And you would set x equal to 0, right? So set x equal to 0 to get y-intercepts. And we're actually expecting two of them. Okay, so it's going to be 0 minus 2 squared over 25 plus y minus 6 squared over 20 equals 1. So 4 over 25 plus y minus 6 squared over 20 equals 1. You can write the 1 as 25 25ths so that you can subtract properly. And you basically just get 21 over 25. So sorry about the ugly numbers, but it is what it is. And you have y minus 6 squared equals 20 times 21 25ths. You can reduce this to 4/5 if you like. But it doesn't really make the problem any simpler. You have y equals 6 plus or minus the square root of 84/5. And it is what it is. You can rationalize it if you wish, but I think I'm done with this problem. Okay? But these are your two y-intercepts, and they should make sense, right? For example, 6 plus 84 over 5 better be something that represents one of these green stars. You know what I mean? Like, hopefully you're not getting nonsense results. Okay? So these are your y-intercepts. Right there. Okay, any questions on that? Last thing I was asking you to find are domain and range. So that's actually pretty easy now that you have everything in place. Domain and range are such that everything fits in this little red box, right? So for domain, let's write our inequalities or our interval notation. Your x's fit between what two values? So this is domain. These are the two vertices, right? On the ends, these are the two vertices. So the least value of x is -3. The greatest value of x is +7. Right? For range, everything falls between the two blue dots. So you need the y coordinates of the co vertices for that. Oh, I messed that up. I was going to slide my little picture over. Let's try that again. Let me go over here. There we go. Okay, so need a little more space for that, but your values are between -6 minus 2 rad 5 and -6 plus 2 rad 5. So sorry about the awkward numbers, but it's realistic, right? Why would we expect decent numbers when we're square rooting everything? Okay, how many of you did sort of get most of it right? Did anybody get it all correct? Okay, good. So that's a lot, right? I mean, that problem would take you 15 minutes, maybe, of the exam time. Plus, if you get something wrong, you could easily mess up everything, right? Okay. Well, we are ready for me to present to you your two homework problems. Okay? And I actually want to help you with them a little bit, just in that the way they're given is kind of awkward. And so they need to be adjusted before you can kind of start. So here are your two homework problems. So this would go on a separate page. Number 1 is discuss (9 times x plus 5 squared plus y minus 8 squared equals 32). the second one is discuss. This one's really messed up. 6x squared plus 8y squared minus 12x plus 48y minus 18 equals 0. So why am I saying these are messed up? Well, these don't really look like standard form. The first problem's not too bad. At least it's factored. Can someone tell me what's wrong with number 1 in terms of like format? Why is it not really standard form? Blake, what were you going to say? The right side is not 1. Correct. So standard form requires a 1. So what can we do to this problem to make that a 1? Divide by 32. I had a student once say, you could subtract 31. So they were doing this on both sides, and they knew that that would make a 1 on the right, but it really gave them a headache later. Not quite the right strategy there. We want to divide by 32 maybe? It's still not quite the right form. There's still something fishy about this problem. There's something fishy. What is now wrong with this picture? That 9 should not be there. Is there another place we can just kind of tuck it away? Can you think of another place to put it? You're not supposed to have anything on top except the x minus h squared. Where's another mathematically valid place to put the 9? The bottom of what? The bottom of the bottom. Yes, you can actually move that 9 to the denominator of the denominator. It's the same thing as having it on the top. The bottom of the bottom is the same as the top of the top. So it looks like standard form now, and it's easy to interpret what A is and what B is, and so forth, and get the ball rolling. Okay? So format's really important. Not only this year, but next year too. Okay? Let's look at the second one. That one's all messed up. It looks like somebody took my standard form that I worked so hard on and foiled it all out. You know? Grouped all the like terms, shame on them. But what you're looking at here is called the general form, and it is worthless for graphing. Totally worthless. The 6, the 8, the 12, the 48, the 18, none of those numbers mean anything geometrically. So what I think we should do is try to get this back to standard form. Okay? So I will give you the first step and the second step, and I'll let you do the rest. You need to move that 18 to the side. Okay, so go ahead and add the 18 over.
Are we just putting it into standard form, or what are we finding?
They're trying to get it in standard form. But discuss, remember what discuss means.
Oh, we have to do the entire list of things.
Let me show you again what discuss means for your homework.
Is that, okay, so
Discuss. Center, vertices, foci, co vertices, graph, intercepts, domain and range.
You can go back to one else.
It's disgusting. Okay? There's a lot to do. I'm just helping you get it started, see? So let's get that 18 on the other side. And then the other clue I'll give you is you want to factor out the 6 from the 2x terms and the 8 from the 2y terms, like this. And then you can add in a magic number here and here to complete the square.
which means we have to add it on the other side.
And that means you're going to be adding something to the right side, but be very careful what you add. The goal is to keep the equation balanced, not to just add the same things you added on the left.
We're going to add 8 times.
Okay, yeah, so be careful what you put on the right here. We've done this before. Just be very cautious. I got 96 on the right before moving on. Okay? So work on those 2 tonight. Don't forget what discuss means, and have a good day.